Hey, in this video I want to show you various methods on desoldering joysticks from a motherboard. I'm using a DualSense as an example, but this can be applied to any other controller. And these methods are going to be ranging from cheap to expensive, starting at around €5 to all the way €200. And as a disclaimer, I'm only counting the costs that are necessary to desolder the joysticks, so I'm not counting any screwdrivers, flux, solder iron, or alcohol to clean the flux with. So without further ado, let's start with part 1. This is the entry level and it's just about replacing the potentiometers with cheap tools. The later parts I will also show you how you can desolder the rest of the joystick. The best part, however, of this is that you may already have some of the basic desoldering tools at your disposal. The way it works is by attempting to heat up all 3 pins at the same time, or at least 2 pins, so that you can wiggle it back and forth and slowly remove it. Be careful with pulling on it with too much force, as you don't want to tear any vias, as that can make for a more difficult repair. Vias are these brown rings that are inside the holes, and that's what the solder actually sticks to. Without these, the solder has no contact with the rest of the motherboard, and you need to learn to lay traces, which is probably a topic for a whole nother video. I find this personally easier, but if you worry about the amount of force required, or if you do not have a PCB clamp, you can also just snap off the potentiometer before soldering if you plan on replacing it anyways. Especially if it's worn, because then it belonged to the trash to begin with. All you will have left is 3 pins which are not connected to each other, and you can take the pins out with your tweezers while you melt the solder. This is easier to do if you do not have a PCB clamp and you are just looking at a quick swap of potentiometers. Afterwards, you still have to remove the leftover solder in the holes, and you can do this with very cheap tools, such as a solder wick, which is like €2 to €3 on AliExpress, or you can use a desoldering pump. And I do want to emphasize quality does matter here. There's some very bad wicks that don't work at all, and there are some that are really good. If you do use solder wick, do add some flux. That really helps. And if you're instead looking at buying a desoldering pump, I recommend buying one with a replaceable silicone tip. If you get those that are a bit hard, it's very difficult to remove all the solder at once, and it makes so much more of a mess. If that tip burns, you toss the entire pump. Whereas if you have a desoldering pump with a replaceable tip, you just replace the tip and that's it. And because the tips are soft, you can create a better seal around the hole and you can suck more out. So that's it for removing the potentiometers and the solder in the holes. Now let's move on to part 2, where we move on to the rest of the joystick. This method includes using the manual pump again. This time it's not as easy to remove the joystick first and only use the pump to remove the leftover solder. So first I add some low melt solder to a pin to lower the melting temperature, and I use my soldering iron at 400 degrees Celsius. Then I come in with the pump to suck out the solder. You can check whether it has successfully removed all the solder by wiggling the pin back and forth with any tool you have at your disposal, such as a plastic spudger. And although autofocus is not playing nice here, you can see that the pin moves, so it's not stuck to the motherboard, and it is fully cleaned throughout the hole. This would have been a lot harder to do with a desoldering pump with a hard tip, which is again why I don't recommend those types. My current desoldering pump is an SS03 knockoff that I bought for about €4, and I was able to heavily use it for 6 months straight before it started to wear out. Namely, the locking button would not keep the pump in tension, but I am still able to suck the solder out by keeping the plunger pressed in and letting go of it when needed. And you can also see that in video that I don't use the button, but rather I let go of the plunger. Something else that you will also encounter with these manual pumps is that it gets clogged easily. And you don't often see this part in tutorials or explained on how to do it. So you can just screw open the pump and do a deep clean ever so often. But what I like to do in a pinch is just stick the tip of the iron in the hole and press the plunger at the same time. That gets most of the clogged solder out. At the end, before pulling on the joystick, I check which pins are not desoldered fully through yet, because these need a second attempt. So I add some fresh solder again on those pins before using the pump to remove it. And I repeat this until all pins are loose. And afterwards you can slowly wiggle out the module out of the motherboard. But be careful to not force push this out, as you can still take some VS with you. So do this gently. We can now move on to part 3, removing the module with solder wick. This has roughly the same costs as removing it with a desolder pump, but it depends on which brand wick you purchase. With wick, flux is your best friend, especially if the wick you're using, like mine, does not extract much solder on its own. Flux ensures the solder flows from the hole to the braided wick. This is not my most favorite method if the holes you try to desolder still have the pins in them, because it's very tricky to remove all the solder around the pin, increasing the likelihood of accidentally removing the vias. And if you're not careful and rub the solder wick on the surface of the motherboard, you can also leave scratches that can introduce shorts. If you move around the solder wick on the board, it's therefore important to lift it up slightly and then move it to where you need to, rather than sliding it across the motherboard and introducing scratches. Secondly, because you are adding more mass, which is the wick itself, that you have to heat up, you may have to increase the temperature of your soldering iron. This is mainly the reason I don't like using solder wick, because I usually use around 400 degrees or less, but this was not enough and I struggled with the first few pins for several attempts. So for the last 2 or 3 pins, I had to increase the temperature even more. But then my flux burns and it's not as efficient and it's more difficult to clean up. Here as well, I use a spudger to check whether the pins are fully desoldered, and if it's not, then I repeat the process. It may require a lot of retries due to the wick not cleaning the holes consistently, and in my case, using the wick took me the longest compared to other methods in this video. So all in all, I don't recommend this method because the pins in the holes prevent you from reaching all the solder that you have to extract. And if you want to stay on the cheap side, I recommend to stick with a pump instead. Removing the solder from the holes if the pins are already removed is incredibly easier. If only we could remove the pins before we could use the wick. That would be ideal, right? Well, we can do that with some additional tools, and I want to show you that in these next parts. Part 4. Cutting up the joystick module. This is a destructive method, and I recommend to use this only if you replace the entire joystick and you do not plan on reusing the old one. The benefit of this method is that you do not have to worry as much about taking out the vias due to all the pins still being stuck. I estimate this to be a sub €30 method. I bought my Knipex branded flush cutters for €19, but you also have some cheaper and more expensive ones. And then you also have the solder wick or pump, which is around €3 to €4, and a pair of tweezers. Before clamping down the motherboard, you will need to cut the joystick. First, cut in the 4 corners. Then the side opposite of the button can be removed with a pair of tweezers, but be careful of the sharp metal edges where you cut it. Then you can bend over the 2 sides, and you can cut these to separate them from each other too. Now the 4 mounting pins of the joystick are all separated, so you can desolder them individually. So again, I'm just adding some fresh solder here, and you can see how easy these can be removed because one of them just fell by heating up the joint without pulling on it. For the other ones, you can use your tweezers and pull them after heating up the joint. Then there's one more piece of metal and the green plastic which you can cut too. These are not soldered down, but they're tricky to remove without cutting them. So just snap them in half and you can remove them with your tweezers as well. Finally, there's the button and the base. You can cut the legs off the button and be more destructive, but in case you want to reuse the button, here's how you remove it without destroying it. I tried showing it here by rotating the motherboard. I basically do the same as I did with the potentiometers in the beginning. I heat up 2 pins and I wedge it up, then I do the same on the other side, and I alternate until the button is loosened. As promised, at the end you are left with empty holes that are great for using the solder wick on. Though you can still use a pump if you prefer it that way. Part 5. Brute forcing with needle nose pliers. This method involves heating up the pins on one side rapidly while pulling on the joystick from the other side of the motherboard. You will need some sort of pliers, such as needle nose pliers, so that you can firmly grab onto the joystick module. My Knipex needle nose pliers cost me 24 euros, and it's on sale now for 14 euros. With the cost of the pump or solder wick, this brings it to around the same costs as the previous method. And similarly to the cutting method, the potentiometers are already removed, as I have shown them how you can remove them with just a soldering iron in the first part, so I won't be covering that a second time. I only knew about this method a few days ago by the YouTuber Save Our Stuff, and I just had to try it. In his comments he also mentioned he uses 420 degrees Celsius, so I also copied this. Because I discovered this method late, it's also part of the reason why this video is uploaded a few days later than I had initially planned, because I wanted to experiment with it and add it in this video if it was worthwhile. And in short, I think it is simple to do, but there is a risk that you should consider as well when doing this. This method works because you are slowly prying on the joystick on one side while heating up the pins on that side as well. Then when those solder joints have hardened, you move on to the other side and you pry over there too. You repeat this until the joystick is loose. This is similar to how you wedge the button out in the previous method, where you cut everything away. I named this method brute forcing for a reason. Here's why this is risky. I noticed when you pull on the joystick, the entire motherboard flexes with the movement. Meaning that if you pull hard enough without heating up the pins, you risk bending or in worst case breaking the motherboard. For that reason alone, I personally won't be using this method, but you also have a higher risk of tearing the vias due to pulling on it while it is still soldered. I'm also not a fan of using 420 degrees Celsius for this method. As you can see, my flux burns at this temperature, but perhaps that's just a flux issue and it may work with better quality flux. I think for me, I should keep it at 400 degrees Celsius. Fortunately, with this being my first attempt at desoldering the joystick using this method, I did not tear any vias, and I left the holes undamaged. These are now ready to be desoldered with solder wick or a desoldering pump. I'm skipping over that part because I already showed how to do that, and we can move on to the next part. Part 6. Using specialized joystick removal tools. There are a few variations of this tool. The first variation was made by Greg, and I personally bought a knockoff from AliExpress, mainly due to the high shipping costs. But if you are in the US and you are interested in a tool like this, I do recommend getting Greg's original tool, as it is of higher quality. The one I have is from December last year, and you can see how discolored it is now compared to December. That's because the knockoffs don't have the coating that soldering tips usually do. Recently I also came across another variation by Bitro Gaming, which seems to speed up the process even more. I don't own this one, so I don't know how well it works, but the idea is that there is a hole on the side of the removal tool where you can stick a pump into that extracts all the solder in just one attempt. And I actually think that's pretty cool because it saves a lot of time. All of these tools have the same purpose. Heat up all pins at the same time, then easily pull on it from the other side. This takes the least time out of all other methods, but you still have to remove the leftover solder in the holes, of course. In this video, you can see that I removed the joysticks from 3 motherboards, and not counting the time to remove the solder from the holes later, it took me a total of like 7 minutes to desolder the joysticks. Sometimes I skip using the flux, and sometimes I do use it. It speeds up the process, which is important because I use the maximum temperature that my iron goes to, which is 480 degrees Celsius, because the whole block of copper has to be heated up and remain heated. So I don't want that heat to be on the motherboard for longer than needed. Hence, I use the flux. These tools require some preparation before you can use them on the motherboard. The holes where the pins go into need to be filled with solder for it to make a good connection. Otherwise, the pins will not melt. Temperature is not the only thing that matters for soldering irons. You need to maintain this temperature while you desolder the joysticks. So the soldering iron's wattage also matters. I recommend to use a soldering iron that has at least 60 watts of power. Otherwise, you may have difficulties heating up the entire block. If you notice it takes too long before you can remove the joysticks, that is an indication that you have to refill the holes with solder. I just recycle some scrap solder that I removed from my desoldering pumps instead of using fresh solder because it's cheaper, and it works equally well if you add flux on the motherboard. Beware with PS4 controllers. You can see that the tool doesn't fit on one of the joysticks because of the PCB clamp, so you have to rotate it or take it out and do it manually. This does make it less stable, so be careful there. At the end, you are left with 3 motherboards without joysticks, done in less than 7 minutes, and there's next to no risk to get broken VS. This method is great if you're a hobbyist or you own a store and you go through many controllers a day. If you have a second soldering iron, you can also use that one iron exclusively for the tool, so you save some time not having to replace it with a regular tip constantly. You can also do a hot swap of the joysticks and save more time. So instead of removing the solder, you keep the desoldering tool on the motherboard and stick a new joystick in while the solder is still a liquid. I don't recommend this method for 3 reasons. 1, the motherboard is exposed to a lot of heat while you replace the joysticks. 2, if you use Hall effects or TMR joysticks, with the high temperature of the tool you risk overheating the sensors on those joysticks, which is bad for their circularity performance. And 3, the most important reason, I think, is because you cannot ensure it is flush on the motherboard. Joysticks can be soldered diagonally on the motherboard if not all pins are fully through the holes and pressed down on the PCB. So simply take your time and remove the solder before inserting a new joystick. At the end of this video, I will also show you how I solder joysticks and make sure these are not soldered crooked, as this affects the circularity. Now it's time for my favorite method, using a desoldering gun with a heated tip. There are different types. Some have a manual plunger with the heated tip, and these are relatively cheap at around 30 euros. Then you also have others, like mine, are fully automatic and they use a vacuum to suck out the solder. These are more expensive, at around 130 euros for mine, but the processes are somewhat the same, so you can follow along with both types. The one I use is the Proskit SS331. If you do purchase one, check which model you buy, as there are 3 versions depending on which outlet your country has and what voltage the outlet provides. With the desoldering gun, I add flux, but I personally don't bother with using low melt solder on my first attempt, but it can help if you want to use it. I have my desoldering pump at 480 degrees Celsius. This is quite high, and I do this because I want to reduce the time that I have to keep the tip on the motherboard and still have consistent results. It's fairly straightforward. You keep the tip on the pin until the solder melts. You wiggle it a bit to make sure it moves, and then you press the trigger. And if you have a manual plunger with a heated tip, then you just press the button to desolder it. That's the only difference. I also do not bother with removing the potentiometers beforehand, because they can also be removed with the desolder pump. The gun also needs regular maintenance. After a couple of joints, you have to clean the tube to avoid burnt flux getting stuck in there, and to avoid having solder solidify at the end of the tube. This can block it and prevent you from desoldering anything. Then there's also the glass container, which has to be emptied and cleaned. If I take an estimate, I do this after desoldering about 15 controllers or 30 joysticks. It takes 10 minutes to clean, it's not a big deal, but I did have a gun before this and I did not clean that one for an extended period of time. After trying to remove it, I broke the heating element. So do not wait around with cleaning the tube itself, just do that after you're done, before turning off the station. And the glass container does not need that much maintenance, but still do it regularly. There are also ceramic fiber filters in the gun and in the station, which should be replaced frequently. You can purchase new filters or buy a sheet of ceramic fiber, and you can cut out pieces, which is cheaper. This specific desoldering gun uses 3mm thick filters, so make sure you buy the correct thickness in the sheet if you go that route. The Pros kit comes with 3 tips. These vary in diameter, and I use the smallest one, 1mm. This is perfect for the joysticks that you have to desolder. The other 2 larger tips, those are a bit more difficult, so I don't even use those. You may also not remove all the solder at once, especially if you don't add low melt solder like me. So similarly to a manual pump, I check each pin with a spudger, and I add some fresh solder to the ones that are still stuck. Then I come in with the desoldering gun for a second attempt. After all the pins are loose, you can slowly wiggle the joystick out. Sometimes if only one pin is still stuck, you can melt the solder with the gun while pulling it out. That makes it a lot easier. I think this is my favorite method, and I have been using this in all of the joystick installation tutorials that I have posted so far, because I don't have to worry about removing the leftover solder after removing the joystick. I also want to take the time to show some appreciation to the AliExpress sellers that I have bought the desoldering gun from, because they have honored the Pros kit 1-year warranty and sent me a new heating element when mine broke. I don't often expect this from AliExpress, and I was very surprised by this. So I will leave a link to this tool, along with any other tool that I mentioned in this video, in the description. These are not affiliated links, though I do have an affiliate link for AKNES' website, where you can purchase Hallpi or Gulikit TMR joysticks, or any of the controllers that AKNES sells. I will also leave this in the description. The last soldering method I want to show you is by using a hot air station. The one I used is the Otten ST862D, which I bought for around €180 at the time, and with the coupon I had, I only paid $160. Now, unfortunately, the first part of this video is a bit out of focus. For some reason, my camera decided to focus on the soldering iron instead of the motherboard. But what I am doing here is adding some fresh solder to all the ground points of the joystick, because these tend to take more heat. So adding some low melt solder will decrease the overall melting temperature on those joints. After that, I add some flux and I turn on the hot air station. I have it set at 400 degrees Celsius with 50% airflow. You may have to play around with this depending on which hot air station you use. I also haven't used a hot air station that frequently for joysticks because it's not my most favorite method. So even I am still playing around with what temperature and airflow I should use. Whenever you use the hot air station, it's very important that you keep moving the nozzle so that you equally distribute the heat. You don't want one area to be much hotter than the other, otherwise you won't be able to pull it out. Additionally, if you overheat the PCB too much, you may have something that's called popcorning, where the layers of the PCB are separated. In that case, you can basically toss that motherboard. So now you just heat up the joints evenly by moving the nozzle around. Do not move the nozzle too close to the motherboard, as that can increase the likelihood of having that popcorning phenomenon. At least 3 cm distance is sufficient. If it is not melting when you apply heat for an extended time, you can increase the airflow or temperature. And some other tips: be careful that the motherboard will still be hot to the touch even after you remove the joystick. And if you use a PCB clamp like I am using, with these metal clamps on each side, they will also soak up a lot of heat because it's just one block of metal. So let it cool off before removing the motherboard. And also check if your hot air station has a cool function to basically turn it into a cold air station. This particular one that I am using does have it, so it just helps to speed it up. Too high airflow can also knock off other components of the motherboard, as they can fly away when they are desoldered and you get close to the motherboard, so be careful. And lastly, you have the option to do a hot swap of the joystick while the solder is still molten. However, as I just explained with the joystick removal tool section, I don't recommend it because you risk not soldering the joystick flush on the motherboard, which is even more of a problem if some of the plastic melts on the other side of the board. This is very common for hot air stations. So make sure you scrape off any plastics, if there is some, before soldering a new joystick. And ideally avoid the hot swap method, unless you are experienced enough to avoid those molten plastics and can ensure that the joystick sits flush on the motherboard. Because it can save you a lot of time if you repair many controllers of these on a daily basis. So I'm gonna let the rest of it play out. You saw me use the pump with the hot air gun. It's very easy to do because all the solder will be fully molten throughout the hole. But you can also just use your soldering iron with the pump if that's something you're more comfortable with. Or as I show on the other joystick, you can use some wick as well. Now that's it for all the methods that I know of on how to desolder the joysticks. I'm curious to know if there are other methods that I have left out that you may know, so please let me know in the comments. And as a bonus, I want to show you how I solder new joysticks on the motherboard, ensuring that it is flush to optimize the performance. The joystick that I will be installing on the motherboard is one of my custom TMR joysticks that I made by mixing parts and lubricating the inside. If you want to see how I do that, I have another video going over this process. Because the TMR joysticks are heat sensitive, I don't use 400 degrees Celsius, but I solder around 370 degrees instead. I start with soldering down the 4 big mounting pins of the joystick. To ensure that it sits flat, I start with only one pin and I press down on the joystick module while the solder is in its liquid form. Then I solder the one in the opposite diagonal and finally the last 2 mounting pins. Afterwards, I solder the sensors. Now, there are 2 important things to mention here. One, the sensors often have some movement in them. They can rock back and forth. So what I do when I solder these down is I push them against the joystick module while I solder them. And second is I only solder one pin of each sensor and I alternate between them. This is again because the TMR joysticks are heat sensitive, so I want to lower the chance of overheating the sensor. So when I work on one sensor, the other one has time to cool off a bit. Finally, for the button, this is separate from the rest of the joystick module, so it can be soldered crooked even if the rest of the joystick is flush on the motherboard. What I do in this case is I press down on the button while I solder one leg. And you can make it a bit more comfortable for yourself by placing the thumb cap on the joystick now, so that you can press on it easier. So while you have the solder in the liquid form on one pin, you have the button pressed and held down until the solder solidifies. Then you move on to the pin diagonally opposite of it and you'll repeat the process. And afterwards the final 2 pins. On the other joystick, it was even more noticeable how crooked the button can be. So this is why I use this method to solder the button flush on the base of the joystick. Well, the video is so long it became nighttime by the end of the outro. This was a very long video and it was in the works for a long time as well. I think I started recording like 2 weeks ago. Editing took me a week and I had to reshoot some clips because it wasn't working out well. This is, I think, the most effort and the most time I ever put into a YouTube video because I think it will be useful to a lot of people and I hope to do this more often to help as many people as I can. I want to thank you all for watching. If you enjoyed this and want to see more videos like these, please hit the subscribe button. We're almost at 1,000 subscribers. And in my next video, I will be modifying every aspect of the controller using Extreme Rate's available products that they sent out to me to test. And after that, I have another large project in the works that I think it's going to spark up an interesting topic about TMR and Hall effect joysticks that might shine a different light in how people perceive them and how these are being marketed in a way that can cause a lot of misinformation to be spread. I think that's a very important video that I wanted to make for a long time already. So thank you for watching again, and I'll see you in the next video. Bye-bye.